So what I'm going to be doing for this is going to be doing a circuit board from scratch. So if you guys follow the URL shortener or the link to the Dropbox, and you'll download two files, schematic.sch, that is what you see right here, and then you'll also have cheater.board. So if you open up cheater.board, it'll show you the complete board that after it's already made and stuff. So when you guys are playing with this on your own, you can open that up and see how I did stuff and try to reverse engineer what I did. So the schematic here, it's pretty simple. All it does is it counts from 0 to 9 a whole bunch of times. So nothing special, but it gets all the basics across. Any questions yet? Sweet. All right. So here we have a 555 timer. That's our clock. Then we have a thing that decodes, or it's a counter chip. Turns it from clock pulses to binary, 4-bit width. Then we have a chip that goes from the 4 digital inputs to a 7-segment display. Now, when you first open up to when you first go to create a board, it'll say it just doesn't exist. So you can go ahead and hit yes. Now, you have this pile of crap right here. So this is called your rat's nest. And you'll see that it has these orange wires on here, kind of. Let me try inverting the screen. Is that better? All right, cool. All right, so your rat's nest, so you have all these yellow wires. So that is the shortest path to the next component. Now, when doing a board layout, you want to just kind of have an idea of what you're looking into before you start placing stuff down. So in this case, I can hit this move thing here, and I can pick something up, and I can put it down. So this is a USB port. All it does is give me power, but I know I'd want it on the side of the board because it'd be silly to put it in here in most cases. That said, I have done that intentionally before. So I have that on the side of the board. And I know I have my 555 counter. It doesn't matter really what orientation I put it in yet because I don't know where the easiest orientation for it is. So I'll just plop that down. Then I have this next component. Oh, great, now I can't see what's on the screen. All right, so I'll just set those down like that. And so you can see that these lines are actually just getting messier. So right here in the lower left corner, you see a thing that says rat's nest. So if you hit that, it regenerates all the shortest lines. So in this case, yeah, I can tell that this is in the correct order right here. So yeah, the 555, the counter, and the decoder. Now, I can go in and check to see where my resistors are, so I can just throw them in the general vicinity of where I want. So in this case, resistors go from R1 to R7. So I'll find R1 to R7. That is right there. And I'll just plop them down right there. And something else you can do is you can select multiple things by hitting the square box right here. And then you actually have to hold down Control and then right click with this move thing selected to affect multiple things at once. Be careful though, because like if you have the clone thing selected, then you have a whole bunch of extra parts. If you have the delete thing selected, then you just removed half your schematic. But first you can just hit undo and you'll be right back to where you used to be. Yes, you can rotate. So I'll do it with this bunch here, but it works exactly the same as only one. So with move thing selected, you can hold down Control to select everything, and then you can right click, and then that rotates it by 90 degrees. If you middle click, it'll actually put the component on the other side of the board. In the schematic, if you middle click, then it'll actually just flip the component. So, yeah. So it can be useful if component isn't quite oriented correctly. So I'll regenerate that rat's nest now. Alright, so I can see that the yellow line goes right to this pad right here. So I'll just throw that there, throw that there. Just do this a bunch of times. Alright, so now I have my current limiting resistors there. And actually, now that I'm looking at this, I can tell that this is on the wrong side. Now you can work around that. There are some times where you're not in a convenient place and there is nothing you can do about it, short of just throwing away the whole board and starting all over again, which is something I do. I'll just quickly lay everything out. I don't even bother putting all the wires in. But once I kind of have an idea of what the board's supposed to look like, I'll delete it, start all over again. And I can actually save a bunch of time that way by going in, knowing what it is I'm doing. Alright, so power, I can go ahead and find the power line. Let's see. Oh, so right clicking, it changes what kind of wire you're setting down. So in this case, it just goes straight from point A to point B. I don't recommend doing those though because it looks extremely amateurish. So yeah, you have rounded things. That's useful if you're doing high frequency stuff. So I'm just usually doing this. Nice 45-degree angles everywhere. If you middle click, then it flips the side of the board you're working on again. So in this case, red is top layer, blue is bottom layer. And if you hold down Shift and then left click, then you'll drop a via down. So now I can go between the top and the bottom of the board. And actually, second thought, before I start laying out power, I'll go ahead and just assign everything else in the area. So I have all these current limiting resistors. I have a button with R12 on it. So that needs to go somewhere. I'll just put that right there. Happy little button next to the happy little trees. 555, I have a bunch of capacitive components, so C5, C4, 14 and 13. So C3, 13, 14, C4. Oh, sorry. All right, bypass capacitors. So a lot of times you'll see them just kind of off on their own on the schematic. So what the bypass capacitors do is it effectively shorts out the antennas you're creating. So every time you have a line, it has a little bit, or every time you have a trace, it has a little bit of inductance. And if you're running a high frequency through it, you now have an antenna. Depending on what you're doing, you could either get people with ham radios mad at you, to the FCC being mad at you, to a compliance engineer being mad at you if you have to go through that. It might also just make your TV do weird things if this is just kind of being breadboarded out. So C1 through C3 are my bypass caps. So bypass cap, you just want to put it as close as you can to whatever component you're trying to bypass. Between the power and the ground. C3. Alright, so diode, I'll just throw that over here. So if you're having a hard time finding out what something goes to on a schematic or on the board layout, you can hit this eyeball tool right here, and you can click on a component. and then you can go to the board. Oops, wrong board. You can go to the board, and you'll see that this component here is highlighted. Very useful if you have a fairly crowded board, and especially if you have all the reference designators disabled. Reference designator is this R14 right here. So EAGLE works in layers, so I don't need all these enabled. Like, I don't care about the value of a part as I'm laying it out typically. So I can go in and disable the top and bottom values. So in this case, you just saw that 118 disappear. Let's see. So real quick, I just need to move these other 4 components. All right. Okay, running rat's nest again, so I have all the shortest paths. I'm going to give myself a little bit more space here. All right, and that should be good. All right, so I can wave this thing around and then see where it goes. So in this case, it goes on pin 4 of that IC right there. And I can tell that the resistor attaches to this diode. So I can go ahead and just kind of plop this down. C5. I'll just set that there. C4. C13. Run a rat's nest again. All right, now we can actually go in and start running traces between things. So there are 2 trace buttons you can use. You can use this one here, the route to assign traces between pins. And this is the one I recommend doing 99% of the time, because this doesn't let you just make arbitrary traces. I can't click out here and start doing stuff. The one right below it, though, wire, you can create arbitrary traces. And sometimes useful, but so rarely that it's probably not even worthwhile you really knowing about that. But if you start using the wrong tool, like if I were to use this here, it looks like I'm doing something reasonable right now, but it doesn't have highlighting, which I'll show you in a bit. Plus, I don't know if that's even a good trace or not. It might be shorting through everything. I have no way of really telling. All right, so using this trace here, I'll just go ahead and click on one of those, and you can see that the top part of this resistor is much lighter than the bottom part. That means that the trace is supposed to go there. And you can also tell all the other places that are highlighted. So that just means that's common. In this case, I think it might be power. If you right click on something and go to properties, it'll tell you what it is. So plus 5 volts here. So continuing on with routing, so I have that diode again, between resistors, so in this case I can go between traces right there. I need to be careful with how you actually do this. Sometimes if your pins are too close together, you just need to go through a smaller wire. Because this is all low current, I can use a 0.01 wire. That's typically as small as I go. But you can see I could probably fit 2 traces between there. But, okay, also real quick, so you can, all your wires and stuff like that go onto a grid. The grid is typically invisible, but the size right here determines how closely you can move things. So you can see that I have actually much finer resolution now. So that's too close. So that right there, my board house should still be okay with, but you need to check with your board house to see what kind of dimensions that you need to stick to before you start running into problems. All right, so set that down. That's probably ground. All right, so I'm going to call the 555 good for now, and I'll start actually running things to other components. So I have this IC right here, so I can start putting the components next to it, or actually in this case I can move the components off to the side because I don't need them to be super close. All these are doing is setting options within the component itself. Let's nest again. All right, now from here I can start running the traces. So call that good. That's good. Now, right here I ran into an issue. So I have the two resistors on the wrong side of each other. So all I have to do there is get rid of that wire. Oops. And then just swap these two resistors. So again, this is why I like to do a rough draft of my schematic and then delete it, because then I can have a screenshot of all this and I know just basically which ways I want various things to go. Now, I did the same thing here, but I don't care. So here I can actually just run a via, then I can go under the board, which puts me right under everything else. Another via, and now I'm right where I need to be. So something to be careful about with vias is if you're running a high frequency or something, then you'll actually start degrading your signal. It'll also screw up any kind of impedance matching you're doing if that's something important to you, if you're doing antennas or something. So just be cognizant of that. But vias, if you have a small via and you fill it in with solder, it can actually take a lot of power. So you can use that as an efficient way of running power between layers. Like it'll take way more power than trace, unless it's just a massive trace. And a quick note about power and traces. So small trace here can handle a lot fewer amps than, say, a bigger trace right here, or a mondo trace like, let's see, like this or something like that. And there are a bunch of free calculators out online. There's also one I highly recommend for the Android cell phone called Droid. So it has various calculators in it, including a how much power can your trace take calculator, and it'll tell you, like, if you want only a 20-degree voltage rise during full current, then this is a trace you need. Very handy tool, and I have it out when I'm doing most any of this stuff. Droid. So I think there's a free version, but then mine. Good program. I went ahead and paid the $4 or whatever for mine. All right, so the clock from the 555, I needed to go into this chip here, and I'll actually go ahead and also just connect it up to this type of stuff right here. So run another via. I have to go underneath all of my bottom layer right now. And something I also like to do is I like to end wherever it is I'm going to be ending, and then I start the trace again from the other side. That puts me right in the middle, because you can tell in the pad above that I'm not right in the middle, and usually doesn't make a difference, but because I design boards where I only make one-offs and stuff like that, I like to spend some time on aesthetics. And because I also build all these by hand, then I'm the one who has to suffer through any board decisions. So I do the best I can to make a good board. Actually, this piece here, that's small enough where it'll fit right between those pads. So again, you have to check with your board house, but Park, which I use, they have reasonable prices. One thing I don't like about them is all their boards are purple, and if you're trying to figure out where a trace is going on an actual board, it's hard to see the purple solder mask. But good price, and they use advanced circuits for their manufacturing, so they have high quality boards. Let's see. Go ahead and run a rat's nest again. And actually, so I can... actually, yes, I do. Thank you. So something else. So if Eagle doesn't really know what it is you're wanting to click on, you can right-click and it'll change what's highlighted. Yeah, you can kind of see that. So in this case, I'm wanting that kind of horizontal line. So that's very useful if you're trying to delete something. But do be careful when you're trying to clear a trace or something. Let me come up with an example. Okay, so that's a weird thing, but if I go in and just delete this trace here and I click again, it deletes everything. And if you have a single trace that's running through most of your circuit board, like if you have the plus 5 volt line or something like that, and you're zoomed in way close like this and you don't notice you just wiped out half your board, then it'll ruin your day. So just something to be cognizant of. Crap. All right, so that's 3, then this is a 4th line. Run rat's nest again. All right, so I'll also go ahead and just knock all these things out just to have them done. So in this case, I'm also going to be playing around with the vias and running through components. Alright, so via here. Now, because this thing is a through-hole component, I don't need to actually run a via to go back up to it. I can just run straight to that, and then that is perfect. I can also use that as via, so I don't have to go laying around a bunch of extra ones if I don't need them. Alright, so that's knocked out. And also just go ahead and knock these out. Anyone have any questions as I'm doing this? So the whole thing started because I couldn't get to sleep one night and I just wanted to learn how to do circuit boards anyway, so I brought my little creation to one of the actual electrical engineers at work, and he pretty much tore it apart, which I am very grateful for. Like, I had no idea what a bypass capacitor was, so I thought it was ridiculous that they were putting all these capacitors everywhere when they could just be put into one small area and be a lot more efficient. Well, I didn't know what a bypass capacitor was. Even after he told me that, I didn't understand what a bypass capacitor was. I just knew you were supposed to put it as close as you could to your ICs. And now I understand exactly what they're there for, and actually, a great story about that. I had an intern at work, and he needed to lay out a bunch of WS2812 LEDs, and this guy was so incompetent, I just gave up on the whole bypass capacitor thing. So he built his little project, and I'm a month later doing something in my scope, and I had it set to sweep fairly slowly. And every second, I would just see this massive burst of noise. His LEDs were putting out so much noise that my oscilloscope was acting as an antenna 2 meters away. Alright, so basic layout is actually getting pretty close to being done. Going to go ahead and run a power trace just all the way up here. Okay. Oh yeah, right, back to your question though. I've been doing this for a few years now. And I just managed to somehow get paid for it, which I am very grateful for. I absolutely love my job. Say again? No, it does not have simulation in it. Now that Autodesk has purchased it a couple weeks ago, it might get something. I'm hoping though, if nothing else, at least improve the user interface, because the thing was made back in like the early 90s, and it shows because they haven't touched it since. Oh, and then if you want to see where a particular trace goes, you can use that same eyeball thing, and you can highlight that trace, and you can see everywhere it's supposed to be. So in this case, I can tell I need to run a line down there. That one's good. That's good. Need to flip that around. Then I'm pretty close to being done with power. And of course, if I was doing this for real, I'd be spending a lot more time on my traces. Like this thing here, I would not consider to be acceptable, but it's good enough for a quick demo. Let's see. Now, I have all these ground traces here. I'm not going to worry about them yet, because what I'm going to do is I'm actually going to put in a ground plane. So ground planes are great because they also suppress noise and it makes it a lot easier to do a circuit board layout. But one thing to worry about with a ground plane though is if you're doing anything with high current or something that needs to feed back into itself, like a regulator or something like that, especially switch mode regulator, you have to have the current loop as small as you can get it. Otherwise you can have a part that starts oscillating, and it'll take a while to figure out what's really causing that. Let's see, I'll just plop this in. All right, and I can go ahead and knock out the ground plane now. So a trick I found with the ground plane, you want to create a single layer, like so. And you can't just go into properties and name this ground. It throws a fit for some reason. I'm not even sure why they give you the text box in there if you can't edit it. But you have to go in and hit name. Type in ground, G&D. And then what I'd like to do is I will copy this, paste it. You can't really see it, but I did do that. I can move it over there and show you. But I have two things just right on top of each other. So I'll right click on one of them, properties, and then I'll set this to bottom. So now I have two ground planes on here. Now, every time I hit rat's nest, it'll fill all that stuff in for me. So unfortunately though, it's difficult to really work on your circuit board with all that extra color in there. And I don't know how to kind of un-rat's nest it. So what I've taken to doing is I'll just move a corner and hit undo a couple of times, and now I'm back to something where I can actually see what's going on. But now in this case, all my ground yellow wires have disappeared just because it knows that it's actually going somewhere now. Alright, so power, whatever that thing does. I think this might actually be my clock. So go down there. In this case, I don't need a view. I can just go straight down. And then right here, I really didn't need a via either, but then I'd have to have a via somewhere just so I don't have my traces touching. So via up here. You go. So these resistors here I chose. So you have what's called a package, and that determines what what size and shape your component is. So the package here, that's DIP 8, so dual inline pin, and there's 8 of them. In this case, the package for the resistor is a 1206, so it's 0.12 inches by 0.06 inches to the side. And you can see that just right in here. In 0805, it's about half the size, a little bit more than half the size. That's the preference I use when I'm doing something by hand, because it's small enough where it doesn't take up too much room, but still big enough where I can put it down with a pair of tweezers. Every now and then I might go down to a 06, 04. That starts becoming a little bit unmanageable, but if I only have to do a couple components, not too bad. Much below that, though, you can't really touch. So on that sleepless night, when I learned how to use this, I had no idea what a package was. So I ordered a 1K resistor, and I was just expecting to have a 3-hole quarter-watt resistor for some reason. I got something so small that I took a picture of near a grain of rice. You could probably put 10 of these resistors end to end on that 1 grain of rice. Yeah, I can show you a picture of that later on if you guys request. Oh yeah, and after I'm done with all this, I'll be out somewhere where you can find me, and feel free to just pick my brain in person. And I'll let you know as soon as I figure a place to do that. Maybe that table over there, since I don't see anything on that table. Alright, so here I have a pull-up resistor for this reset line. Or maybe pull down resistor. Yeah, it's pull down. Alright, so I ran that, and now I think I'm actually done with. Nope. Alright, so that's a ground. Alright, so with that, all the unrouted wires are gone, so I have a reasonable circuit board layout at this point. Now I can hit this and, okay, so I can see that the ground isn't actually connected in here. So what you can do here, you can manually put down a via and then go and name it ground. Actually, before I name it ground, I'll show you what happens if you don't have it properly named. So the ground plane just avoids it. So if I go and name it ground, if I do that again, the unrouted wire disappears, and this is actually connecting the top and bottom layer. From here, I just clone this a bunch of times, and whoever has my circuit board will see that I just went nuts with this. And I do this because it helps short out any kind of high frequency signals you may get, and it also allows you to keep a low impedance with all of your grounds. Run this again. Alright, so it's ugly as sin, but that should work. I don't see any more unrouted plate things. Now what I can do is, normally it's on the screen, but my screen's kind of shrunk down right now. But if you go to Design Rule Check, DRC, you can load up a file that you create to say what all in it is and is not acceptable. So, like right here, my traces can't be any fewer than 8 mils between each other. Can't be any more than 8 mils between a pad and a line. Various distances, like how close something can be to the side of the board. What drill sizes are permissible. So in this case, what I did was I got a file from Oshpark, and I will hit check. And unfortunately, didn't find anything wrong. So I'll make a problem just so you can see what happens. I'll move this via right here. So now I'm actually shorting power to ground. So run this design check again, and it came up this thing saying I have an overlap. Now, just because something shows up on here doesn't automatically mean it's bad. If I go to this thing here, the design rule check would be throwing a fit right here because I'm doing some crazy stuff. But if I look here, it's okay. And yeah, so you can see I have all sorts of overlaps. Now here, you do need to be careful. If you're not doing all this stuff by hand, you can't really get away with this because the via will actually suck away all the solder from these pads. Yeah, more tomfoolery, but this board definitely got this job done. And then the reason I did this is because these are actually fairly high current devices, which is why I also have a large trace right here. And I don't expect to take any more than a few amps, but it is also going through inductors, so you can occasionally have some spikes with that. So I'm going to move that out of the way, rerun the design rule check, and everything's good. Okay, so what do I do about making this thing easy to read when I actually go to assemble this? Because I have all these reference designator here, and when it actually goes to be assembled, they'll be taken away because they're on top of the pads. So what I can do, highlight everything, and then there's a command here called smash. I don't know why it's called that. I probably would have picked something better, but you can hold down Control, right click, and now it's hard to see, but you can now take the reference designator and move it independently of the component itself. Now if you move the component, the reference designator will still stay with it, but you can actually go in and start putting these things down in such a way where it makes sense. And it's hard to see. Holy crap, that's hard to see. Right, reference designators. Okay, so you can see that the reference designator actually has a line going to the component it's associated with. So it helps prevent you from doing something like that, which will really screw you up later. So C2, R10. In this case, I'm going off the board, but quick demo, doesn't matter. All right, now in this case, I have a via that's going through my reference designator. If there's nothing you can do about it, then it's permissible, but it'd be hard to see which component that actually is when you really only have a 5. Now, if you have the original source file, then it's not a big deal. You just have the source file open as you're doing your layout. But in this case, I can move it here. I can also move it right here. That'll show up just fine. Because in this case, I will have a white silk screen on top of a purple solder mask. Okay, so I'm right here. Now, how do I actually go and get this made? So you need to generate what are called Gerber files. So if I go to CAM processor, save the board first. Now, if I go to CAM processor, I can open up. In this case, it's just called Oshpark Gerbers. I think I got this straight from Oshpark. I also did a few modifications to it, but this will take your various layers. So in this case, I have my top copper, bottom copper, silk screen, solder mask, and it'll actually turn into a Gerber file. So what Gerbers do is it tells the board house exactly how to make your part. So if I go to process job, it'll just knock that out for me. And now I can go to a site like Oshpark and I can give them the Gerber file, and then 10 days later, they'll have a circuit board for me. And these badges here, I'm pretty sure the guy used Eagle to make these, so the exact same techniques that I'm using here, he used to make your badge. All right, what would you guys like to see now? Because that's the end of my demonstration. So any questions, anything you want to see? Yes, sir.
At the beginning you said, you wouldn't recommend, I know Eagle's free, but you wouldn't recommend it. What's a non-free?
Ultimate Designer is awesome, but you're looking at $6,000 for a single license. Eagle, the free version kind of sucks at best. Like, it's even worse than their paid version. But then the licenses get so ridiculously complicated because I think if you do the math on it, there's over 100 license variants you can get. So that quickly turns into a mess. So this is actually a much bigger board than it needs to be. So Oshpark, the company I go through, it's $2 per square inch. But what I can do is I can shrink this down. And now I just cut the cost down to a quarter of what it originally was. But in this case, no, what is that? 4 or 5 square inches, $10. Yeah, then you have your USB header, that's 50 cents. Every component on here probably isn't more than $1 or $2 if you're only ordering one of them. The resistors here, ordering one at a time, you're looking at 10 cents a piece, which is ridiculously expensive compared to ordering 10,000 of them where you're looking at 0.001 cents a piece. But now that scale.
It costs more to ship them.
Yes, it absolutely costs more to ship these.
I buy them by 10. The smallest I buy is 10 units.
Mm-hmm. Yeah.
Last did you order a single quantity was 11 cents, quantity 10 was 11 cents, and it went down to like 7 cents.
Yeah. But and a quick note on DigiKey. I don't think I have the plugin on my laptop, but
That was total price, same price.
yeah. For a rush job, I had to order. Screw it. I'm not doing anything private. Oh yeah, so Oshpark, they will make. Yeah, Oshpark. You order one set of boards, so that's $2 a square inch, and you get 3 boards out of it. OSH. So, yep, OSHPARK.com. And I'd show you that process, but I don't trust this network, and yeah, I don't want to use my personal credentials on anything. All right, so DigiKey. Yeah, I don't think I have that Grease Monkey. No, I must have it. Yeah, so there is a Grease Monkey script you can get called DigiKey Advanced Search. I was talking to the guy recently and found out he actually does work at DigiKey, but the Advanced Search plugin that he makes makes DigiKey a lot easier to use. So if I go to product index, then it has a nice layout for everything. Or it would if I wasn't on a projector. But so let's just go with resistors. Now I know I want a surface mount resistor. That's not it. Oh. Oh, that's why. Wrong set of resistors. All right. So surface mount resistor, I have 442,000 of them to choose from. So when you are looking for components, you want to hit this in stock thing, which will cut it down to less than half. Package, I know it's a 1206 that I'm wanting, so package / case, just find a 1206. And let's just say I want 1K. All right, so I have these 5 here to choose from. They're 10 cents a piece. Really not all that bad. But then shipping on it will cost you $15. Yes?
I remember in the beginning you said something like a grade and thickness of these wires, right?
Yes.
You seem to do it by experience, but I was wondering if you could maybe show, like, from the specification, how a beginner can make sure that what he does is correct. Like, let's say from horsepower.
All right, so are you talking about for how much current?
He does some specification. So how do I get from that to proper setting?
Okay, yes, I will show you. So I will look up Oshpark design rules. And so you can see how they want things to be named, and it has to be named exactly like this. So design rules. All right, 6 mil minimum trace width. So I can go to my design rule checker and sizes, and minimum width is 6. But let's say it wasn't actually 6, it was 15. Well, now I just failed every one of my widths because I went with an old specification. Did that answer your question?
Yeah, but that sounds like a test after you've done your design. Is there anything you can do before you do the design?
So you can do this as you're doing your design. Just run that tool every now and then. You can also just look up their design specs before you really get started. So I can see that. Let's see. Yeah, so I can see that I need 15 mil clearance between the trace and the side of the board. So as I'm doing this, I just know that if I was doing this, like I could be here and not have a problem, but I can't be here. And that's just something I can keep in my mind. But it comes with experience too. But like if you go to upload something that fails those checks, well, if you have something that's going off your board, then Oshpark, I'm pretty sure, will tell you. But if you have something that fails because you have something that looks like this, something that's just going through everything, Oshpark doesn't care. They have no way of telling that is bad. Because, yeah, the Gerber files, it's kind of like compiled code. You take all your comments and stuff away. All right, anyone else? All right, so I have about 10 minutes left. I can hang around here for another few minutes, but then I guess I can just go ahead and hang out at that far table over there if anyone has anything. So cheat should have, cheat would not have a schematic. You'd have to just rename cheat to, or cheater to schematic.brd. But there should have been a,
All I see is the schematic.
There were just 2 files and that's it.
yeah, the second file, crap. Well, sorry about that. I will fix that and then you can re-download it. That was my bad.
What ground for? Like, is it
So those aren't actually grounds. So those are mounting holes.
Oh, they're not ground though.
Yeah. So if I go here,
Yeah.
so that basically is a giant via. I don't think I'd call it a via though. Oh, it is a via.
Not actually used, right? Just for the
No, so this is how I actually mount my device.
Can we see the download link again? Because I didn't get it.
Yeah, so as it turns out, I screwed that up, so I will have that fixed in a few minutes.
Okay. Yeah, I don't need to download it right now. Just,
Okay,
I
so,
just want to write it down. Or I'll just take a picture.
yeah, let me,
Picture will be
oops.
faster.